required array. So on which data you tried, Yashika? Numbers or strings or something else? Records.
Ma'am, that yes was for you asked which sorting. You have asked. We have started with sorting, and for that I said yes.
Mhm. So you did not create the array of numbers or array of strings, etc.
Ma'am, not array of strings.
Then with numbers,
Yes, ma'am, just started.
accept display is proper. You are
Yes,
able
ma'am.
to get the input from the user.
Yes, ma'am.
Okay. So we discussed on the we discussed last time binary search on the numbers. Then also we discussed the selection sort algorithm on strings. Okay, so if you want to do the sorting on numbers, you will take the array like this, array of numbers. Okay, then if you want to do sorting on the strings, you have to take the input in this way, array of strings. Okay, we saw the accept and display function for this, how to declare array of strings, how to take the input for this. Okay, so I asked you to practice with the strings assignment before you take the array of strings, isn't it? Then after you get your input, okay, you have to work with three algorithms. Okay, पहले bubble sort apply करो. So actually if you implement all this, then it will help you to clear your concepts. Huh? On numbers first, array of numbers पे, so on array of numbers try bubble sort, selection sort, and now we have seen insertion sort algorithm also. So that also you can try insertion sort. Okay, and binary search algorithm. Binary search, recursive and iterative. Binary search, recursive, and binary search, iterative. Okay. So this is your first task. On numbers, try all these algorithms. So that will be helpful for brushing up the concepts of the required algorithms. Okay. So ये सारे algorithms जो हमने theory में पढ़े हैं, implement it first with the simplest input, that is with integers, array of integers like we have taken in sets. Okay, so here you can refer input function, accept display functions, you can as it is you can use from set assignment. Okay, सेट से लो array of input कैसे लेना है etc. Okay, ठीक है. So refer set assignment here for input and complete all these algorithms. That is your first task. Then second step is on the database. You have already created this database for items, isn't it? Your third assignment. That is database using array. So refer that assignment. Okay, input from that assignment, take it as it is. Accept display function वही से लो, and then you can try all these algorithms again. Okay, records पे कैसे करना है searching sorting. Okay, so try all these algorithms on database also. Then third step is you have to take the data for array of strings. Okay, array of strings का data लो, and like these input output functions I have explained you last time. Okay, for array of strings. I'm not telling you about single string. It is array of strings, like array of names, names of persons, names of the cities, etc. Okay, I say this is the third input which you will be taking, and algorithms will remain same. Just the input will change. Okay, so here you need to use string compare and string copy functions. String compare for comparing the values, and string copy for uh, when you are interchanging the values. Okay, at the time. So this is what is your third assignment. So instead of directly going to this string, my suggestion is try all the algorithms with simple numbers. So that will give you confidence that your algorithms are proper or not. Okay, and I want the proper algorithm, the pass wise output. Okay, pass wise output is expected. So whatever thing we did in the morning during the class, I asked you to solve certain examples on paper. Okay, pass wise on paper. So if you are able to do solve on paper, then you can check whether your program is giving you the pass wise correct output or not, because passes of bubble sort will be different, selection sort will be different, and insertion sort will be different. Okay, so whether your output is correctly you're getting or not, that you will be knowing by looking the pass wise output. Okay, so pass wise output is expected, then only we will come to know whether your algorithm is working properly or not. Clear? Any doubt here? So I'm not going to show each and everything. So I think we have done the discussion on selection sort and bubble sort algorithms last time on array of strings. Okay. So and we have discussed almost all the algorithms in the theory class. Okay. So try to implement by your own if possible. And today, 1 minute, I will. Sorry. So is this clear? What is the agenda of this assignment? Okay, assignment में क्या क्या करना है? Is it clear?
Yes,
Then
ma'am.
okay, we will revise the algorithms again. We'll say that insertion sort is available.
मैम
हाँ.
अगर हमें सॉर्टेड अरे पहले ही मिल गया n-1 टाइम्स हमें करने की जरूरत ना पड़ी तो आगे के पासेस दिखाने हैं उसमें.
See, आपको पता नहीं है ना, at the time of implementation you don't know what input user is going to put. Okay, that will be runtime input which user will give you, isn't it? So you have to run your algorithm for the maximum time, मतलब जो expected है n-1 passes, that you have to do, because that will change according to input. Best case है, worst case है या average case है, that you cannot predict at the initial stage. Okay, when you are writing the code, you have to write the code by assuming that it will be worst case input only. Okay.
ओके मैम.
Yes, because it will be difficult for us while writing the code. Okay, how we will come to know कि user क्या input डालेगा. So we are not able to decide the passes at program time. Okay.
And ma'am, while writing on paper, should we consider all the cases like n-1 up to if we get the sorted array before that?
No, then you can just mention that pass 4 is also same, pass 5 will be also same. Okay, or further passes till n-1, that is till fifth pass will be same. Okay, like that you can put a comment.
Okay, ma'am.
So are you able to see the code block screen?
Ma'am.
Yes. Okay, so we have discussed this binary bubble sort and selection sort functions last time. Accept display किया था for array, isn't it? We have done the accept for array of strings and display for array of strings. We have also discussed why this is declared as a matrix. Okay, and now after you have obtained the sorted output, हमने बबल सॉर्ट देखा था, टू सॉर्ट इन द असेंडिंग ऑर्डर. बबल सॉर्ट यूज करके हमने असेंडिंग ऑर्डर में सॉर्ट किया है. एंड सिलेक्शन सॉर्ट यूज करके हमने डिसेंडिंग में किया है, बिकॉज वी हैव फाउंड हियर मैक्सिमम. ओके, so selection sort is used for arranging the input in descending order. Clear? And here we can check that after finding maximum, we are doing the swapping only once in that pass. Okay, before the end of I loop, we are swapping here only once. So this is selection sort. Okay, whereas in bubble sort, we are doing the swapping immediately when adjacent elements are not in the required order. So swapping is done multiple times here in the nested for loop. The jth for loop, we are doing the swapping for every uh, not required order adjacent elements. Okay, so these are the two algorithms which we discussed. Now after you have done this, you can go for implementation of insertion sort algorithm. Today we have discussed insertion sort algorithm, isn't it? So what we do in insertion sort, we have to compare, okay, compare the current element from the latest element in the previously sorted array. Okay, so see here. So I'm showing you insertion sort algorithm not on strings but on the records. Okay, the algorithm will remain same. Now you know what is your input, but we will discuss here just the method. Okay, so for I is equal to 1 to n, 0 is not taken because we know that the first element will be always sorted. When I equal to 0 is there, it will be always sorted. Okay, so you can imagine in the array. Okay, in the array, if there are elements starting from 0th index to the index n minus 1, okay, the 0th element is assumed that it is already sorted, so it was not considered, and current element is from 1. So first element will be compared with its previous element, that is 0th element. Okay, so this is the current element I equal to 1 in the first iteration, and that element, current element, is called as temp here. Okay, instead of temp you can also call this as current because we are not swapping here. Okay, so you can replace temp with current also. This is our current element. Okay, the current element is the ith record, अभी जो loop चल रहा है वही. Okay, then we are comparing with the I minus 1, that is the previous element. Okay, latest जो element हमने हमारे previous array में है उससे हम compare कर रहे हैं. Okay, because see, when we are having current element as I, so I के पहले सारे positions पे sorted array है. They are the elements before that are always in the sorted order. Okay, so I minus 1, it will be checking with I minus 1 and up to 0th element. It will check up to 0th element until it is getting the greater element. Okay, so greater element मिला, so it will just shift that greater element. Okay, this is shifting. So all the greater elements will be shifted one position right. Okay, and then after shifting those greater elements, when we come to the proper condition, so ये loop क्यों end हो सकता है? एक तो we have reached the smaller number, तो smaller number reach हुआ तो ये termination condition true होगा, and that's why the loop will end, or we will reach to 0th position and then the loop will end. Okay, so सारे elements अगर greater है तो we will reach to j is equal to 0, otherwise or because of this condition the loop will stop. Okay, so that is the proper position for insertion. j जहाँ पे भी रुकेगा, that will be the proper position for inserting the current element. So current will be inserted at that jth location. ठीक है, clear? This is insertion sorting. So by seeing to these conditions only we will come to know कि कौन सा sorting algorithm है. Okay, यहाँ पे loop चल रहा है. First loop is I equal to 1 to n, and here in second loop we can check that comparison is done with the last index than current element. Current element ith position पे है, so उसके previous index से comparison we are doing in the reverse order. Okay, so I minus 1 to 0 we are comparing. So this is insertion sort. Clear? And shifting is done here. So this is insertion sort. It will tell us. Okay, and selection sort में कैसे किया था? Selection sort में we are finding here minimum or maximum, and we are doing the swapping only once after the inner loop. After this J's loop, we are doing the swapping only once. This is selection sort. Okay, we are accessing complete array to find minimum or maximum element. And in bubble sort, we are doing the we are comparing adjacent elements. So here, if you can see, j and j plus 1 are compared. So that is the bubble sort algorithm. Okay. So like this, by seeing to the conditions, you can identify which algorithm it is. Okay. And you have to display the passwise output. That's why before the end of the ith loop, we are displaying here. Complete array we are displaying. Okay, here also before the end of the ith loop we are displaying the complete array. That's why we will get the passwise output like you have solved in the morning. Okay, similarly you will be getting the output, and in this is on the records. Okay, so here also you can display the passwise output. Okay, before the I loop ends you can call display function. Okay, so that you will get the passwise output. Only final sorted array is not expected. How you are processing, how your passes are working, that is important in this assignment. Okay, and after these sorting algorithms are done, we have already discussed the binary search, recursive and iterative algorithms in the class. Okay, so try those algorithms on this. Binary search. Okay, this is recursive or iterative. Can anyone guess? Iterative है या recursive है या algorithm?
Recursive.
Recursive, because we are calling binary search inside binary search. Okay, and another algorithm also you have to write, which is iterative algorithm. Okay, yes, this is iterative algorithm. Okay, we have discussed both, but still I'll revise. Okay, this recursive algorithm, what happens here? See, we are passing the key. This in the now our input is string input. So our key also will be single string. Okay, our database is or our array of strings is our complete set where we are looking for the key. Okay, so this is our input array str, and this str find is a key which is single string. Okay, so that's why it is single square bracket. Okay, so this is a single string and this is complete array of strings. Okay, where we are looking for this particular string. This is key and low and high. Okay, initially low and high will be 0 and n minus 1. So here in this case of search, what we are doing, we are first in binary search we need sorted input. So we are asking the user to be sure that the input is sorted in ascending order. So using any algorithm which you have written for sorting in ascending order, you can use that. You can call that here. Okay. So in this program we have bubble sort and insertion sort in sort ascending order. So we will call that also here first, and then after we are sure, okay, after we are sure, then we can take the key from the user and call binary search. Okay, so 0 to n minus 1 are the initial bounds where we have to search this key in the array str. Okay, so these are the 4 inputs required, and these bounds will change every time in every recursive call. Okay, these bounds will change. Key will remain same, the array will remain same. Complete array we are going to pass, but the bound in which we are going to see that key will differ every time. Okay, it will be lower and lower bound. Okay, means the bound will decrease. The number of elements in which we are looking, that set will go on decreasing in every recursive call. Okay, and this binary search is returning a position if the position is available. Okay, if it is found, then that position will be something other than -1. Otherwise -1 will be returned. अगर नहीं found हुआ तो -1 return होगा. Okay, so we are returning the position, and we are checking what is this there in the position value. If it is -1, we are displaying not found. Otherwise, we are saying it is found at this location. Okay, position +1 location, because 0 से start किया है, that's why while displaying we are saying 0 को हम first position बोलेंगे, क्योंकि user को नहीं पता that we are using array etc. Okay, the users are not knowing your programming language or programming constraints. Okay, so they will assume that first से मेरा database start होगा. There is no 0th position like that. Okay, that's why while displaying we are saying the position +1. So यहाँ पे बाइनरी सर्च में अभी क्या हुआ, 0 and n-1 will be initial bounds. Okay, and we are checking until low is greater than high. Okay, this is the base condition that we will stop. Low, whenever low becomes greater than high, that should be the stopping condition or base condition where recursive calls will end. And for every recursion there must be a base condition, proper base condition. Otherwise your recursion will tend to infinitely. Okay, infinitely call करेगा otherwise. So the base condition is must. So this is the base condition to stop the recursive calls. Okay. Otherwise, whenever low is less than high, we have to find the width of that bound, current bound, low and high जो bounds है हमारे, उसका mid निकालो, and so it is simply on the positions, the indices. Okay, and we know that the input is in sorted order. That's why this will calculate proper mid, and now we can apply this logic. अगर mid से equal है तो if our string is matching with mid, that means ये हमारा अभी string compare we will be using. Here we will use string compare function to compare the key with the string of mid. Okay, and it will return 0 if the match is exact match. Okay, key से अगर match हुआ तो 0 return करेगा, because this is the difference between the ASCII values of each pair of characters. Okay, that's why it will return 0. So 0 return क्या मतलब कि exactly match हुआ है, then we can return the position as mid. Mid is the position for that. Otherwise, if string compare key is greater than this, so when these are the two parameters passed for string compare, so when it is greater than 0, it returns greater than 0 value. That means it is string find is greater. Okay, that is key is greater. की ग्रेटर है तो हमको किस एरे में सर्च करना है, किस सब एरे में सर्च करना है, लेफ्ट और राइट. की अगर मिड से ग्रेटर है then we have to search in the right sub array. Okay, so that's why binary search will be called recursively again for right sub array. Right sub array मतलब क्या, mid +1 to high. High will remain as it is and low will change to mid +1 for the current sub array. Okay, so ये another instance generate होगा binary search का, and पहला जो instance है which we started with 0 to n-1, that will be pending for some time until this next instances will completely get solved. Okay, that is how recursion works. जब तक ये recursive call work नहीं होगा completely, this will not get completed. This will be pending. Okay, so it will call another instance of binary search. So ये execution of our final binary search, the original binary search call, it is dependent on its descendant call. Okay, so ये call पे वो dependent है. Now otherwise the possibility is अगर की मैच नहीं हुआ है या फिर की ग्रेटर भी नहीं है मिड के स्ट्रिंग से, then that means it is key is less than the mid. Okay, that's why we need to search in the left sub array. Okay, that's why low will be as it is. जो हमारा पहला लो था वही लो होगा, but mid will be the high will be mid -1. So the bound will be now changed. Okay, binary search again will be called, but on the left sub array. Okay, so that can again be calling binary search again on its left sub array or right sub array after finding mid. So that will continue until the partitioning is not possible, finding mid is not at all possible. Till that time the calling will continue, or until this gets executed. So these are the two base conditions. एक तो match होना चाहिए mid के key से, या फिर it should the division is not possible. These are the two base conditions. Okay, to start returning from the binary search call. Okay, and it will return to whoever has called it. That value will return to that instance whoever has called it. So finally, after completing calls of these descendants, then finally our original call gets completed and it will return the same value. Okay, जो उसके डिसेंडेंट ने उसको रिटर्न किया है, एक तो मिड का पोजीशन या फिर -1, जो भी उसके डिसेंडेंट ने उसको रिटर्न किया है, इट विल रिटर्न इट एज इट इज टू इट्स ओरिजिनल कॉल. ओके, सो यहाँ पे वो अपने आप आ जाएगा. तो पहले क्या होगा, रिकर्सिव कॉल 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 हो गए, एंड if we get the match, then it will return that position, okay, to its current latest call, then uske previous call, iska previous call, like that till we reach our first call. Okay, so like this it will continue. This is recursive binary search. Okay, simple है, चार ही condition है. एक तो you have to check whether the partitioning is possible or not. If not, then you have to end it immediately. Return -1 करो. अगर partitioning possible है तो find the mid and go to the compare with mid first. So this is second condition. Okay, this is the first condition. This is the second condition. Compare with the mid. Okay, then this is the third condition. Mid से greater है हमारे, and this is the fourth one. Okay, mid से less है हमारा. So these are the only 4 conditions for which we have to write the code in the binary search, but appropriately लिखना है सब. Okay, ठीक है. And similarly, iterative function, we have seen this also in the class, but this is, I have not written it with strings. You have to write with strings. Okay, I have written it with records. So records पे मैंने binary search apply किया है, and here I am using the algorithm iterative. Okay, so here I am checking. So manually I am doing now. जो recursive में automatically हो रहा था calling. Okay, यहाँ पे I am doing it manually. 0 to n-1. I is my lower bound, j is higher bound. So until I is less than or equal to k. Okay, we are finding mid. This k is mid. Mid find करो and then compare it with mid first. The key will be compared with mid first. Okay, match हुआ तो return that k, that is position of mid. Otherwise, you have to check whether it is greater, key is greater than the mid or less than the mid. So, key अगर greater है mid से तो हमारा upper bound जो है वो yes, it is now working on the descending order elements. This binary search is working on descending order elements. That's why की अगर ग्रेटर है तो इट इज सर्चिंग फॉर द लेफ्ट सब एरे. ओके, सो इट इज मॉडिफाइंग j, दैट इज अपर बाउंड मॉडिफाई कर रहा है to k minus 1 if key is greater, because it is working on the descending order input. Okay, so this is also possible कि descending order input है फिर भी मैं binary search try कर सकती हूँ. Okay, but based on the condition that you should know it कि ascending में है या descending में है. So this condition will vary accordingly. Okay, otherwise ascending में है तो I will modify I to k plus 1. Okay, clear, because I will be searching in right sub array in that case अगर ascending में है तो, but descending में है इसलिए if key is greater I will search it in left sub array. Okay, and similarly with the the lower bound you have to modify. If key is smaller, then you have to modify the lower bound as this is on descending order input. That's why. समझ में आया क्या क्या चेंजेस करने हैं? You have to play with these algorithms until and unless you practice it much. Okay, it will not be clear. Mid is equal to int
Yes, ma'am.
high plus low divided by 2 should be there. Where, Bhakti? Where you are talking about? In iterative or recursive? In sorting में नहीं यूज करेंगे हम mid. Mid is not required in sorting here. Searching में चाहिए, binary search में चाहिए. Okay, so searching आप कौन सा algorithm बोल रहे हो? Recursive या iterative? Recursive या iterative search? Recursive में है ना बेटा? See, before we calculate mid, we are checking whether finding mid is possible or not. अगर exceed हो गया है limits, okay, low greater हो गया है high से, then we cannot divide it. Okay, ऐसे condition हो सकता है कि previous वाला हमारा low high both are pointing at the same location. Then we can find out its mid. Its mid will be the same location. Okay, but in the next iteration it will not be possible to divide it again. Okay, low and high if they are pointing to the same location, और ऐसे भी हो सकता है कि adjacent elements है. Low is at 5th position and high is at 6th position. Okay, clear? So how to find mid of it? Mid of it will be again the same element, low. Okay, so we have to stop in this case. So पहले हमने वो base condition check किया कि dividing possible है क्या? If dividing is possible, then only we are finding the mid of it. नहीं तो we are returning that dividing is not possible, मतलब हमने जितना possible था उतना divide कर लिया. Now it is not able to be divided. That's why -1 return करो, नहीं present है वहाँ पे. Okay, so we can discuss this with example also. यहाँ पे हमने डिस्कस किया था कि सपोज दिस इज माय नंबर एरे. ओके, इसको हमने पहले both the cases we have discussed कि 6 है, 6 सर्च करनी है हमको इस एरे में, तो क्या होगा? दिस इज द इनपुट इन द सॉर्टेड ऑर्डर. ओके, these are the indices of it. तो पहले सॉर्टेड ऑर्डर में है क्या वो कंफर्म करना है आपको. की लेनी है यूजर से and then you have to find the mid, but before you find the mid it should be able to be divided. Okay, आपको लो एंड हाई अगर इक्वल नहीं है तो ये वी कैन, अगर लो हाई से ग्रेटर हो गया है then we are not able to divide it. Okay, so dividing possible है तो mid calculate करो and compare it with mid first. Okay, mid से अगर compare नहीं हुआ तो we have to check whether it is the key is smaller or higher than the current mid. Okay, smaller है तो we have to search in the lower half, greater है तो you have to search in the next half. Okay, like that. Again उसका mid find करना है, उससे compare करना है. So we are comparing with mid of the current sub array every time. Okay, and then we are shifting to the left sub array or right sub array. So every iteration में या फिर every recursive call में we are handling the less number of inputs, okay, than the original one. Original में हम initially we are handling all the inputs of the array, but afterwards when we are moving to the next call, then we are reducing the number of inputs to be handled at that particular stage. Okay, because we are neglecting half of the array every time. Okay, so like this you have to complete this assignment. Okay, with all these algorithms, 3 sorting algorithms and 2 algorithms for binary search. Okay, recursive and iterative, दोनों दोनों इस पे आपको करने हैं स्टेप. एंड लाइक आई सेड गोस ग्रेजुअली. ओके, स्टेप वाइज जाओ, पहले नंबर्स पे ट्राई करो, फिर डेटाबेस जो आपके पास रेडी इनपुट्स है उस पे ट्राई करो पहले, so that you will be able to handle the inputs properly. So मैंने यहाँ पे दिखाया आपको रिकॉर्ड्स पे कैसे करना है. तो नंबर्स पे तो एकदम इजी है. ओके, देन आई हैव शोन विद द रिकॉर्ड्स आल्सो कि रिकॉर्ड्स कैसे आपको सॉर्ट करने हैं या फिर सर्च करने हैं. ओके, यहाँ पे देखो रिकॉर्ड्स पे सिलेक्शन सॉर्ट किया. So you can try all these algorithms on every type of input. Okay. Insertion also, insertion sort also on the records itself. तो ये असाइनमेंट कंप्लीट करो आज. ओके, एटलीस्ट नंबर्स पे सारे एल्गोरिथम्स चेक करके देखो whether you can work on these algorithms, whether you have understood or not, and then go for the difficult type of input like that. Okay. Okay, so this is your 5th assignment. ये प्रॉपरली करो क्योंकि नेक्स्ट जो हमारा एल्गोरिदम है, नेक्स्ट सॉर्टिंग एल्गोरिथम्स, क्विक सॉर्ट, मर्ज सॉर्ट, दे आर मोर डिफिकल्ट टू अंडरस्टैंड. ओके, सो ये जब तक आप इम्प्लीमेंट नहीं करोगे आपको सॉर्टिंग का ये फील नहीं आएगा. ओके, so quick sort and merge sort are more difficult. That's why in the theory also today what I asked you to practice on paper first these algorithms. Okay, so passes कैसे होते हैं etc. You should know all these things. कैसे लिखना है आपको. तो पेपर पे जैसे पासेस लिखोगे वैसे ही आपको यहाँ पे भी डिस्प्ले करना है आउटपुट में. ओके, ठीक है. फर्स्ट अंडरस्टैंड द एल्गोरिथम्स एंड देन गो ऑन मॉडिफाइंग द इनपुट एवरी टाइम. अलग अलग इनपुट पे ट्राई करो. एंड यू हैव रिटन द फंक्शंस. ओके, नंबर्स का फंक्शन आपने लिखा है, एक्सेप्टिंग एरे ऑफ नंबर्स, दैट इज आवर फर्स्ट असाइनमेंट, सेट असाइनमेंट. वो फंक्शन एक्सेप्ट डिस्प्ले एज इट इज यूज करो यहाँ पे, एंड उस पे सॉर्टिंग ट्राई करो, सारे सॉर्टिंग एंड सर्चिंग. ओके, देन वी हैव द डेटाबेस इनपुट आल्सो इन द थर्ड असाइनमेंट, एरे ऑफ स्ट्रक्चर्स का. वो इनपुट एक्सेप्ट डिस्प्ले फंक्शन एज इट इज लो, एंड उस पे सारे एल्गोरिथम्स ट्राई करो सॉर्टिंग सर्चिंग के. ओके, एंड थर्ड इज व्हिच आई एक्सप्लेन यू, एरे ऑफ स्ट्रिंग्स, उस पे फिर करो. ओके, तो 3 बार करोगे तो ये आपका एकदम पक्का हो जाएंगे सारे एल्गोरिथम्स व्हिच आर रिक्वायर्ड एवरी टाइम. और रोहित क्या बोल रहा है, कैन वी रिड्यूस द नंबर ऑफ इटरेशन यूजिंग व्हाइल लूप. You can set a variable flag inside if condition. In which algorithm you are talking about, Rohit? Rohit, we are not able to hear you.
Hello, ma'am.
हाँ, बोलो.
लाइक हर एक सॉर्ट में बबल सॉर्ट या और कोई भी सॉर्ट में अगर हम फॉर लूप लगा रहे तो जो सबसे पहला फॉर लूप है n-1 के लिए वहाँ पर अगर हम while लगा दें और सेकंड वाले फॉर लूप के अंदर जो इफ कंडीशन हम डालते हैं अगर i इज ग्रेटर देन i प्लस वन एलिमेंट तभी इफ लूप में जाएगा ना तब
If is
वहाँ पे
not a loop.
एलिमेंट को
If
वेरिएबल
is
को हम
not a loop. Rohit. If is not a loop. It is just a condition.
एक मिनट
It is conditional instruction. It is not a loop. Okay, यहाँ पे जो आप बोल रहे हो, this is not a loop. This is just checking comparison. Okay, conditional instruction है ये. These are the loops. Bubble sort में. And we have already reduced here. If you can see, j is equal to n minus I बोल रही हूँ. So पहले पास में सारे adjacent pairs compare करेगा. Next pass में it will not compare with the last element because we know that it is sorted. So n minus I मतलब it will skip that one element. Okay? ठीक है?
ओके मैम
So like this, ये modify करो so that comparison will not be done with sorted elements. Okay? So that's why we have modified this condition. Okay, and this is not the loop. So we have to do the comparison. Okay, number of comparisons we are reducing by applying the condition here. Okay. Is it good or still you have any doubt?
Ma'am, I was saying that if in the if condition, if we set the flag is equal to 0 and while coming into while loop, flag is equal to 0, iterating through this while your variable is equal to 0. Like I have done it.
You have done it? Can you show me?
Yes, ma'am. I'm trying.
Yes, share करो. Can you share?
Yes, ma'am. I'm trying to share.